Alright, this is lesson 8.2a in trigonometry, trigonometric form of complex numbers. Okay, so notice in figure 3 here, we are making a little bit of a change to our coordinate plane. Normally this is the x-axis, this is the y-axis, but dealing with complex numbers, this is the real axis and this is the complex or imaginary axis. So notice, graphing 2 minus 3i. Remember, everything needs to be written in the form a plus bi, where this is the x and this is the y. So 2, we come over 2 because that's a real number, and because of the I here, that's a complex or an imaginary number, so we go over 2, down 3. If we were to add these together, remember in the last section we took like 1 plus 3i, and we added 4 plus I. Whoops, golly, Gary, come on. Alright, so 1 plus 4 is 5, and 3i plus I is 4i. So we go over 5, up 4, and we end up at that point there. And that's the resultant, that red line there. Okay, same is true with this bottom one we have. We've got negative 4 minus 3i, and we are adding 6 minus 2i. So negative 4 plus 6 is 2, negative 3i plus negative 2i is minus 5i, and that is why they came over 2, down 5 to get to this place right here. So there's my resultant there. Alright, so that is basically expressing the sum of complex numbers graphically. Alright, so trigonometric or polar form, we're going to see if we can keep you from getting too confused here. Right here is my magnitude, my hypotenuse, my radius, okay? And if I have my magnitude this long, and my angle here, I have my direction angle, okay? That's going to give me this point P, just like coming over X and up Y is going to give me point P. Alright, so if I want to know, well, let's do this. Cosine of theta is going to be adjacent over hypotenuse. Okay? What if I wanted to find out how long x was? Well, x then is equal to r cosine of theta, which is right there. They don't explain how they got that. Maybe they do later, but anyway. If you want to find the length of x, you just take r cosine of theta. If we want to find the sine of theta, that is going to be opposite over hypotenuse. Or if we wanted to find out what y is, that's going to be the hypotenuse or the radius or the magnitude equals that. So we've got this to find y and this to find x, depending on what we're given. We also know, according to Pythagorean, that our hypotenuse is going to equal the square root of x squared plus y squared, and we also know that our tangent is opposite over adjacent, or y over x. Now that's old stuff. Alright, so let's turn the page and get moving along with this. Okay, so let's look at this right here. X plus yi. That is this point here, right? We went over x and up y, and that gave us that point there. That's an important point there, okay? Because that is the magnitude and the direction angle. That's the termination point. Also, if you use the coordinate system, you go over x, up y. Alright, what did we say? We said x is r cosine of theta. So if instead of writing that, I'm going to, instead of writing x, I'm going to write r cosine of theta, and instead of y, I'm going to write r sine of theta, and then I'm going to follow that up with, in fact, I'll put this in parentheses, and let's put this in parentheses, doesn't really matter, but I need to put in parentheses the second one because I still have this I that I need to tag on to the end of it. So if we are looking for this point right here, it's this plus this. And we can, in fact, we're going to rewrite this just a little bit because we have some commonality here. We have an R here and an R here, so I'm going to factor out the R. Right? Really, all I'm doing is coming up with a formula. Alright, so I'm going to factor out an R, and that leaves the cosine of theta plus sine of theta I, but they don't write it this way. They switch it around so the I is coming first, because it doesn't matter in multiplication which number comes first in which order. Okay, so we get that. So this is equal to that. Alright, why is that important? Well, we'll get to that in just a minute. But before we get to why we did that, we're going to learn how to convert. Now, this is called the trigonometric form of a complex number. It's also called the polar form. Alright, now you're used to using the rectangular form, finding the x, finding the y, and graphing that point. In the polar form, we're using this formula right here. Alright, so in the next video, we're going to learn how to convert back and forth between the trigonometric form and the rectangular form. And so that'll be the next video.